Hey guys, and we finished up last time on the review with describing the graph on the negative and the positive. What's the difference between both sides? So let's continue the talk. So question number 16 is asking what type of motion is taking place during the time intervals 15 to 30 seconds. At 15, you're at 60 miles per hour. At 30 seconds, you're at 0 miles per hour. That is, you're stopped. You're not moving. 0 miles per hour, you're at rest. So the change is you're going from 60 down to 0.0, which is another word for stop. Okay. Between number 17, between 30 and 40, if you're stopped right here, and as we discussed earlier, this is moving your car in the negative side. Here's 0. Here's positive. Here's negative. So if you're going in the negative side, between 30 and 40, you're stopped at 30, and then you start increasing your speed to 20 and then to 40. Eventually, you're at 40 miles per hour. The thing is, you're going towards the negative side. So between 30 and 40 seconds, you are moving towards the negative side. And moving faster. Does that make sense? And then the last 40 to 50. So if you're going really fast right here, and once again, this line right here is stopped, going really fast in reverse or towards the negative side, however you want to see it. Then you slow down to a stop. So from 40 to 50, you're slowing from a speed to a stop while going to the negative. Or some of y'all, you're going in reverse. So you're going backwards. Cool. All right. So next one, 22. An airplane is flying through the air with a velocity of 145. So this plane is going up 145 meters per second. It's being blown sideways at 34 meters per second. Plane is not going to go straight. Why? Because you have a horizontal sideways vector pushing it sideways. It's like you riding your bike down the street and there's a wind pushing you. You're eventually going to move off to the side, either to the left or to the right, depending on where the wind is blowing you. So this plane goes that way. How do you calculate this? One of the easiest formulas you're going to use this year, you saw this last year, you use Pythagoras theorem, because in reality, you're trying to figure out the C, or the hypotenuse, or the resultant. However you want to put it, it's the same thing. So how do you solve for it? 145 squared plus 34 squared equals C squared. It's really important that when you find your answer, you square root it, because you're looking for C itself. You're not looking for C squared, you're looking for C. So the opposite of squaring is square root. Next one, same thing, but this time the triangle looks like this. And it reads, he's going 34 meters, and then he goes 45 meters, and then 123 meters. So if you were to draw this right triangle again, This side is 45. This side down here, it's not 123. 123 is from here to here. 34 is from here to here. So how do you solve for it? 123. You take out those 34 squared. So you do the math to it, you subtract it, but once you get the answer, you square it. You plug that into the Pythagoras theorem, and you will get your answer. Once again, that's your C, or resultant, or hypotenuse. In this one, it was the magnitude of displacement. Either way, you're looking for the C leg. Okay. Now off to 20. You know, let's give 24. Let's do 25. Let's do it in that order. So on 25, here's what I recommend you do with these. A lot of y'all have issues when you see word problems and you have a lot of values to it, a lot of variables. You freak out. So this is the easiest way for you to do this. It's very difficult for you to go straight from here to your answer. Some of y'all used a method in middle school. It was called the guess method. So everyone used a method, and it was called different. But regardless, I'm going to write down all my variables down here. Doing acceleration. That's my formula. So I'm going to find my acceleration, my final velocity, my initial velocity, and my time. Now I'm going to take my time reading through this to make sure I'm using the right number. Don't rush through this part. While traveling along a highway, a driver slows from 24 meters per second. So he's going 24 meters per second. He slows down to 15 meters per second. So that tells you his initial is 24. His final is 15. And his time is 12. What is acceleration? That is your unknown. I'm going to give you an X. So what's the next step? You plug it into this. X equals velocity final 15 minus 24 over 12. Also, he's slowing down or he's stopping. So you know whatever you get as an answer is going to be negative. Okay. And if it is not negative, go back to look through it to see what you did. So now that we did 25, let's go back to do 24. And this time we're going to do the exact same thing. My acceleration is my final velocity minus my initial velocity divided by my time. Acceleration, final, initial. And you're asking, how do I know what to do or which ones to use? What's that? It's looking for, it talks about acceleration. So that's the formula I'm using. So I break it down here. So let's read. The car's acceleration accelerates at a rate of 3.0 meters per second. 3.0 meters per second. It starts out at 8 meters per second. How many seconds? This is your unknown. Will it take to reach a final speed of 25? Hey guys, on this, there's no right or wrong answer to do this. You just need to read the problem and kind of estimate what is your initial, what is your final. So I'm going to plug that in. 3.0 equals finals 25. My initial is 8. And my time is x. So we're going to do a little bit of algebra in here. Remember the whole crisscross applesauce or butterfly effect or cross multiply? Same thing. So I'm going to put my 3 over 1. I'm going to cross multiply it. So on one side, I'm left with 3.0x equals 25 minus 18. 17. One last step, you cancel the 3. This cancels out, and you're left with your answer in seconds. Do this part, guys. If these problems mess you up, you need to do this. Cool? Nice. Let's continue. We talked about this in class. We talked about vector quantities. These are all vector quantities because it's a force, it's a displacement, it's a position. It doesn't necessarily give you a direction, but a position from its point of origin. Displacement means that by definition, it's from start to finish. Remember our definition in class. Velocity is a speed plus a direction. And then a force is always, a net force is always in a particular direction. If you recall from net forces. We did 32, 33. I love to show you out the hurricane maps or the wind maps of the world. And you know the length of it indicates the strength. You know the arrowhead indicates the direction of the wind. Okay, it could be a wind, it could be anything as long as it depicts the magnitude of the vector. And then finally, I'm dropping a cat, and this cat falls. And if I were to make a line of best fit, I'm going to draw a line through the cats. See that? So I'm going to stop once his paws touch the ground, right there. So, what is this showing? It's showing that for every split second that the cat is in the air, his velocity is going to increase. There's a huge difference whether you fall off your bed and you fall off the roof of your house. What's the difference? You have a lot more room from the roof of your house to the floor to pick up speed. The longer you're in the air, the faster you'll be going. Okay, so the question is, what's happening to the cat's velocity for every second that he is falling? Well, he's increasing. But the acceleration, the rate in which he's speeding up stays the same. It's 9.8. Okay, the acceleration on Earth is always going to be 9.8. So it's constant. Yes, he is going faster, but that rate of increasing speed is going to be 9.8. Okay, so we covered the second section. Hopefully this helps. Remember everything we've done in class and all the videos I showed y'all. And thank you for your time and your patience. Good luck on the test.